Hello everybody and welcome back to another math contest series video. In today's video, we're going to be going over our part 2 of probability. So on the channel, we've already created a part 1 of this video. We have already created a part 1 of probability, so feel free to check that video out as well. And that's basically what we're going to be going over today. And the difficulty level for this problem will be for grade 7 and for grade 8. So let's get started with what the problem is. So probability. So here is our question, and just before I read the question, I'll also pull up the diagram there. So I'm going to start reading the question now. So the question reads, on the grid shown, Jane starts at dot A. She tosses a fair coin to determine which way to move. If she tosses a head, she moves up 1 dot. If she tosses a tail, she moves right 1 dot. So after 4 tosses of the coin, Jane will be at one of the dots P, Q, R, S, or T. So what is the probability that Jane will be at the dot of R? So that's basically what our question is reading, and now I'll go over some. So that's basically what our question is saying to us, and now I'll go over the possible answers. So we have A, which is 1/2. We have B, which is 3/8. We have C, which is 9/16. We have D, which is 7/16. And we have E, which is 5/16. So this is our problem, and these are our answers, and now we're going to be solving this problem. So for now, feel free to pause this video if you needed to solve this problem on your own, and if not, we're going to be getting into solving this problem right now. So the way that we're going to be solving this problem is by writing them in steps. So we're going to be going over 2 different steps, and the first step is so I'm just going to write step 1. So step 1 is to find out the total amount of paths. So if you look at this box here, so what is the total amount of paths that we can get from going from A to each single one of these letters? So we have 5 letters. So what is the total amount of paths that we can get to reach every single one of them? So step number 1 is to find the total number of paths. So to find the total number of paths, there are 2 different ways that you can do it. One way is just by looking at this diagram and counting each single path that you see, but that way will take a little bit longer. And the other way to do it is by just reading the question again and seeing what it says. So it's saying that there's a fair coin, and we already know that there's 2 possibilities to either get heads or tails, and heads leads to moving up in the path, and tails leads to moving right on the path. So we know that if she tosses a coin, she can either go up on the path or she can go right on the path. So instead of doing this, we know that here it shows that she has 4 tosses on the coin. So if she has 4 tosses on the coin, we can just multiply 2 4 times in order to get the total amount of paths in this question. So if we just do 2 times 2 times 2 times 2, which is 4 times, because there's 4 times that we're going to be flipping the coin, we're going to get 16. So 16 will be the total amount of paths that we can go to each one of these letters from A. And even if you counted them, there's going to be just 16 total possible paths. So now that we found out step number 1, which is the total amount of paths, we know that we need to find out the probability that Jane will be at the dot R. So we don't need to find out for P, Q, S, T, we just need to find out for R. And to do this, we can just count the amount of ways we can see to get there. So step 2, we're just going to count we're going to count the possible paths to the letter R. So we know that R is right over here, and now we're going to be counting the total amount of paths to get there. And also we're going to put the probability formula here too. So we're going to write a probability of landing on R is equal to the total possible outcomes to reach R divided by the total number of paths. So here's the total number of paths, which is the dividing, and then we need to the top would be the amount of possible ways to get to R. So possible ways to R. So now let's just count this. So I'm gonna here use a different color. So let's start counting the possible ways to get to R. So we know that we can only move 4 times. So let's just say that the first one, we got tails, which made us go right. We got tails again, then we got head and head. So that is one path because we took 4 coins, and that's just randomized, and we got to R. So we already found out one possible outcome to get to R. And if that way works, then if we just go the opposite way, that will also work. So instead of going that way, we're gonna just go the opposite way. So we're gonna go up here and then like this, because we still went 4 dots. So we go 1 here, 2 here, 3 here, and 4 here. So now we found out 2 possible outcomes to get to R. And now let's change colors again. And now we're gonna go through the center, so like this. So we're gonna go to the center like this. So 1 here, like this, like this, like this. So then we went, there's another 4 dots. So we got tails, tails, and heads. So this way is 3 possible ways to get to R. So the next way is to just go up 1, and then to go tails twice, and to go up 1. So that's also a possible way. So here we have 4 possible ways of getting to R. Then the next way we have is to go up like this. So we go tails, 2 heads, 1 another tail. So that's basically 5 possible ways to get to R. So the final way to get to R is by going heads, tails, tails. And that is our 6 possible outcomes for getting R. So we're just going to write 6 here, and we know that the total amount of possible ways to get R is 6. So here I'm just going to erase everything here so we can rewrite everything. So if you look at the probability formula again, so P R, so we're looking for R, is equal to the total amount of possible ways to get to R, and we found that that was 6, and then the divided by the total amount of outcomes to get to R, which we found out was 16. So 6 over 16 can also be simplified as 3 over 8. So the possible outcomes to get to R is 3 over 8, which means our answer is B. So that's basically this way of finding out how to get this answer. But the other way was also to find out like just by counting all the paths. So I'm just going to quickly be going over that way. So we know that this way we found out B, and let's just check our other way quickly. So this other way is really quick as well, so we're just going to be going over that. So if we look at the diagram right now, let's just find out all the possible paths to get to each one of these. So from going from A to T, how many possible paths is there? So we know that there's just one because we can just go straight. And if there's just one here, then that means it's going to be the same for P because they're the same thing. So we have 2 already. So now let's look for S. So let's quickly just grab a different color and look for S. So one possible way is from going like this, which is 4 dots. One is like this, so that's 2. One is like this, so that's 3. And finally we have like this. So to get to S, there's 4 possible ways. And if there's 4 possible ways to get an S by doing this, then it's going to be the same thing for P as well. And then here we have 4 plus 4, 8, plus 2, 10. And then we already know that R was 6. And we could have just kept on looking. We could have chosen a different color here and then look for R as well. But since we already knew that it was 6, we could just do 4 plus 4, which is 8, plus 6, and 2, which we got 16. So that's also a different way of getting it because we found out that R was equal to 6. And we could have just found out our total possible outcomes by adding them all up, which gave 16. And then we could have simplified it to 3 over 8. So that's basically it for this problem here. And that's also basically it for this video. So thank you so much for watching from Try to Be Useful, and we'll see you guys in our next Math Contest Series video.